Hi, welcome to another episode of Mr. Max. In this lesson, we are going to revise from November 2014 probability section. So, November 2014 final exam probability section, that is question number 11 and 12. Okay, so listen very carefully. So, hope you already downloaded the question paper from our app. Okay, and read that question. Listen very carefully. Okay, let's start. A survey concerning their holiday preference was done with 180 staff members. So there is a survey for their holiday preference. Okay. So how many staff members are there? 180 staff members altogether. Okay. The options they could choose from were two. So they have three options for that stuff. Okay. What are the three options? Either they can go to the coast, okay, or coastal area, or visit a game park, or stay at home. They have three options. Okay, so for their holiday. So before I continue that one, let me quickly draw that table here. Male, female, total, coast, coastal area, game park, then home, and the last one is total. Here male 46, 52, total 98, 24, 38, 62, 13, 7, 20, total 83, 97, and overall total is 180. Okay, so they have three options: either go to coast or game park, or stay at home. Okay, for male, female, and the total. Okay, now look at the question 11.1. Question number 11.1. What is that question? Determine the probability that. So here you have to find the probability. Okay, so like I said on the previous question, when we are revising the previous questions, I told you there are two types of question. Either you have to find the number, or you have to find the probability. So when you write your exam, you have to read it carefully. Is the question is to find the number or probability. Okay, so look at this question here. You have to find the probability. So when it is probability, the number of that particular event divided by overall total how many events. Okay, so don't forget that. Okay, so determine the probability that a randomly selected staff member 11.1.1. Determine the probability that a randomly selected staff member is a male. That means you have to find the probability of randomly selected staff member is a male. Okay, so only one condition is a male. Doesn't matter is he preferring to go to coastal area, or a game park, or stay at home. No, nothing. Only one condition, that one must be a male. So total how many males are there? Don't think of anything about these numbers. Total how many males? 83. That means probability of being a male is 83 divided by overall how many people are there? Overall total is 180. So probability is 83 by 180. Either you can write is something given, or the option they could choose from. Okay, it is nothing given that they want the answer as a decimal, or a fraction, or a percentage, whatever may be. Okay, so you can write in either 83 by 180 or 0.46. You can check in your calculator. 0.46 or 46%. Okay, any answer you can write. Okay, Next question, 11.1.2. Does not prefer visiting game park. So there also you have to find the probability and what is the condition. Does not prefer visiting game park. So that is the condition. He doesn't want to go to game park. So there is no problem for him to go to coastal area. There is no problem for those people to go to home or stay at home, not go to stay at home. Okay. Only problem is they don't want to, doesn't prefer visiting game park. Okay. Are they talking about male or female? No, they are not saying anything about that. Okay. So it means that you are not supposed to take any of these number. You are supposed to take the total, because in this question they are not saying male or female. They just want does not prefer using game park. That's all. Okay. So it means that this 62 is not allowed. That is the total of game park. Am I right? Okay. So it means that 92 is fine, 20 is fine. Okay. So what is the probability? Probability is 98 total of coastal. Okay. Then total of stay at home is 20 divided by the overall total, that is 180. Check in your calculator what is the answer for that one. That is 118 by 180, so it is 0.66. 0.66. So it means that probability of does not prefer visiting game park is 0.66. Okay. So here let me explain the same question in a different method. Okay. Here what is the question? Probability of, you don't want to write both of this one. Okay. You can just write which one is easy for you to understand. Okay. So here what we did, does not prefer game park. So the other ones is fine. 98 and 20. So what is the probability? 98 plus 20 divided by total 180. Okay. So there is another method. Probability of does not prefer game park means that probability of not game park. Game park. Not game park. Probability of not game park is the same as, maybe some of you remember what is, how can you say this one, B complement. You remember that first, you have to watch that first video, okay, of this probability section. Okay. So B complement means we are not allowed to take anything from B. A complement means we are not allowed to take anything from A. Okay. And probability of A complement, that is 1 minus probability of A. Okay. If you straight watch this video, you can't understand what I am saying here. Okay. So if you want to understand this one, you have to watch that first video of this probability section. Okay. Where I explained with the PowerPoint presentation. Okay. So probability of A complement is 1 minus probability of A. This A complement is the same, or B complement. What is probability of B complement? Is 1 minus probability of B. Okay. So this B complement or A complement is the same as not A, not B. Okay. So probability of not game park is the same as probability of game park not, or game park complement. Okay. So it means that instead of this A, it is game park. That's all. Okay. So how can we write using this complement formula? 1 minus probability of game park. Okay. So it means that 1 minus Probability of game bark. Game bark, how many? 62. So what is the probability? 62 divided by 180. Check in your calculator. In your calculator, you will get the same answer, 0.66. Okay. So this is another method that you can solve this question. Okay. So try to understand. If it is too difficult for you to understand, then just leave it. Do the lemon method or this easy method. Okay. So this is the theoretical method to find the answer of this one. Check in your calculator, you will get that same 0.66. Okay. Okay, so that is 11.1.2. Okay, now let's go to 11.2. Question number 11.2. Okay, let's go to question number 11.2. 11.2. What is that question? Are the events being a male and staying at home independent events? What are the two events given? Are the events being a male or stay at home? Stay at home. Are the events being a male and stay at home, okay, are independent events or not? Can you tell me, do you remember what is the condition that what is the formula that you studied to prove two events A and B are independent? If two events A and B are independent, the formula that you studied is probability of A times probability of B. Can you remember that one? That is probability of A intersection B. You have to remember this one. If two events A and B are independent, if you want to say like that, this condition must satisfy. Okay. In this question, what are these A and B? A is being a male and B is stay at home. Okay, so if these conditions satisfy, then we can say that being a male and stay at home are independent. Okay, so now let's try to find separately what is probability of A. I told you A here being a male. Okay, so let's try to find probability of A or probability of being a male. A stands for being a male. Okay, so male means doesn't matter coastal or game work or home. Okay, it must be male. So what is the total male? 83. So what is the probability of being a male? 83 divided by total 180. Okay, just leave it like that. Probability of what is the B here? Stay at home. Okay, so probability of stay at home. Okay, stay at home, they are not talking about male or female. Stay at home. So stay at home total how many? 20. Okay, so what is the probability? 20 divided by 180. Okay, now probability of A times probability of B. Probability of A times probability, our probability of A means probability of male. Okay, so probability of male times probability of stay at home is equal to 83 by 180 times 20 by 180. Check in your calculator what is the answer for that one. 0.05123. 0.05123. Okay, so here guys, it is better to write 4 or 5 or 6 decimal numbers. Okay, there are some questions I remember maybe the first two are equal, then the remaining are different. Okay, so if there is a slight difference, then we can say that it's not independent. Okay, so you have to write it's better to write 5 or 6 or whatever decimal, the full decimal number. Okay, okay, so probability of male times probability of stay at home is 0.05123. okay, now let's check this one. So this part is sorted out, left side is sorted out. Okay, that is this one. Okay, now let's check this one. Intersection, probability of A intersection B. So intersection means what? Intersection means common. Remember that one theory part, first video. Okay, intersection means common. So probability of, so it means that probability of A intersection B means that probability of event A in our case being a male. So probability of being a male intersection B in our case it is stay at home. Okay, stay at home. So it must be both common, must be a male and stay at home. Okay, so it must be a male and stay at home. How many people are there? Male stay at home 13. That means 13 over 180. Check in your calculator. What is the answer? It is 0.07222. 0.07222. Can you see this one? Left side, what is the answer? 0.05123. Right side, what is the left side? What is the answer? 0. This one. Right side, what is the answer? 0.07. Both are different. Am I right? Okay. So it implies that probability of male times probability of stay at home is not equal to probability of male intersection stay at home. So what we can say, it implies that probability of being a male and stay at home are not independent. You must have to write that sentence, otherwise you will lose 1 mark. Okay, probability of being a male and stay at home are not independent. You have to specify that one. Okay, so that is question number 11.2. now let's move to question number 12. Okay, let's go to question number 12. Question number 12. Look at that question. A password consists of 5 different letters of the English alphabet. How many letters in that password? 5 letters. Okay, each letter may be used only once. So total how many letters in the alphabet? 26. There are 26 letters. Okay, how many letters in our password? How many letters are there? 5 letters. Okay, and what is the next sentence? Each letter may be used only once. So you are allowed to use the one letter only once. If you use a P here, you are not allowed to use P again here. You understand? Okay, then what is how many passwords can be formed? How many passwords? What do you want to find? The number, not the probability. Okay, so like what I said, 2 types of question. Either you have to find the number or you have to find the probability. Okay, so here in this question, how many, that means you have to find the number. Okay, so how many passwords can be formed if 12.1.1 all the letters of the alphabet can be used? So first question is, okay, so let me write that password position here. 1 2 3 4 5. Okay, all the letters of the alphabet is used. So one condition, it is not allowed to repeat the same letter. Okay, so for this position to be filled, how many letters I have? All the 26 letters. Am I right? Okay, so assume that I used one letter there. Now how many letters I have? Only 25, because I am not allowed to repeat the same letter. So once if I use one letter here, for this position I have only 25 options. Okay, so the remaining I have 25 options. So I used 2 letters from this 26. So I am not allowed to use that 2 letters again. So how many letters now remaining? 24. Okay. So this position 24. Then similarly this one 23. This one 22. So take your calculator. Try to find the answer of that one. 7893600. 7893600. That means that many options. Okay. 12.1.2. What is that one? The password must start with a D and end with an L. So listen very carefully. Once if you watch that one, let me tell you again the same thing. Okay. Once if you watch that first video, that PowerPoint presentation, okay, then these type of questions are easy, because immediately when you have a question like this in your mind, that pictures will come, I'm sure. Okay, so watch that first lesson before you watch this type of questions. Okay, it's very important. So what is this question? 12.1.2. The password must start with a D and end with an L. So it means that how many letters are here? 5. In that password there are 5 letters. Okay, and they are saying that the password must start with a D. So here it is fixed there D and ends with the L. That means here we don't have any option. Here we don't have any option. They are saying that you have to put that D there and you have to put that L there. We don't have any option there. So you can just consider this one as constant term, or we just ignore that one, because that is not in our hand. We are told to put that things there. It's just like stones here. Now we just want to think about what we can fill, how many options we have here. That's all. Okay, just consider this position and this position as stones, like in that in Bible. Okay, so this one is stone, this one is stone. So now from this 26, how many letters we used? Already used 2 letters. So how many outstanding for this position? 26 minus 2, that is, here I have 24 options. Here how many options? 23 options, because letters are not allowed to repeat. Okay, here how many options? 22. So total how many options? 24 times 23 times 22. Check in your calculator. 12,144. That means if I choose this D and L as fixed there on both sides, then the remaining how many options? 12,144. Okay, let's go to next question. Question number 12.2. Okay, question number 12.2. What is that one? 7 cars of different manufacturers, of which 3 are silver, are to be parked in a straight line. Wow. So how many cars are there? 7 cars. Audi, BMW, Toyota, then Hyundai. Okay, there are different manufacturers. Total how many cars are parked in a straight line? So all that 7 cars are parked on a straight line. Okay, so assume that 1, 2, 3, 4, 5, 6, 7. There are 7 cars there. Okay, now in these 7 cars, okay, they are saying that 3 are silver. So in this, out of these 7 cars, they are saying that any 3 of them, let's say these 3 are silver cars. Okay, these 3 are silver. Okay, first question, that is a given scenario. Okay, now what is the first question? 12.2.1. 12.2.1. What is that one? In how many different ways can all the cars can be parked? So here they are not saying any condition there. In how many different ways all the cars can be parked. No condition, nothing. Read that sentence once more. In how many ways, they are not talking any, don't think anything about the silver or anything in your mind. Nothing in that question. In how many different ways all the cars can be parked. So let me draw the parking spaces here. Okay. So 1, 2, 3, 4, 5, 6, 7. These are the parking space. Okay. So how many different ways all the cars how many different ways all the cars can be parked? Okay. So now how many different ways without any condition? Okay. Assume that this car is parked here. So how many options I have here? Any one of this car, any not this car. How many options I have for this position to be filled? How many options? I have 7 options. Okay, so don't think that okay, sorry for that, don't think that exactly that car. Okay, so for this position to be filled, I have 7 options. Any one of that 7 cars, I have 7 options. Okay, so I parked, assume that I parked okay, this car there. So one car is out. Am I right? One car is out from there. Now how many cars I have there? 6 cars. Okay, so for this position to be filled, how many options I have? 6 cars. That means 6 options. From that 6 options, maybe Benz, BMW, Toyota, Audi, then which one? I don't know. Nissan, yeah, whatever maybe. Okay, so how many cars are there? 6 cars. 6 options I have. So I'm going to park here that one. I have 6 options. Okay, assume that I parked my BMW, this one. Okay, so I parked BMW here. So that BMW is gone now. Now for this parking position to be filled, how many cars I have now? Only 5 cars. Am I right? So here I have 5 options. Similarly here, how many options I have? 4. Here 3. Here 2. Here 1. The last one, I don't have any option because all these four cars are gone. Then I must have to drive this car and park here. Okay, so total how many options without any condition? Just leave all these arrows. So how many options I have to without any condition? 7 times, 7 times, 6 times, 5 times, 4 times, 3 times, 2 times, 1. That is the same as 7 factorial. Okay, check in your calculator what is the answer. 5040. 5040. That means without any condition, that 7 cars I can park in 5040 different ways. Okay, without any condition. Okay, so let me draw my cars once more here. 1, 2, 3, 4, 5, 6, 7. Out of these 7 cars, these 3 cars are silver. Okay, now next question. 12.2.2. 12.2.2. If the 3 silver cars must be parked next to each other, so these people are very selfish. Okay, these silver people are very selfish. They always want to park next to each other. Okay, determine in how many different ways the cars can be parked. Here also let me tell you, watch that first video, that PowerPoint presentation. Once if you watch that one and understand, these questions are just like, it's a free mark. How many marks? 2 marks, 3 marks, 3 marks. Just like a free marks, you can do that. Okay, so try to watch that video, that PowerPoint. Okay, so these 3 cars, silver cars, they want to park together always next to each other. Okay, then how many different options there? So it means that these 3 cars, maybe this guy can come here, or this guy can come here, or these 2 guys can come here, or these 3 guys can come here, or this silver can come there at the back, or these 3 silver cars can park here. You understand? Okay, so like that, how many different ways that you can park? Condition, what is the condition? Only these 3 silver cars. Previous question there is no conditions, okay, but in this question there is a condition. These 3 silver cars must be together or next to each other. Okay, so there in that presentation I told you, when you have a question like this, okay, you consider this one, okay, just to draw something like this, okay, then you consider this one as one unit. Okay, so you can count this 1, 2, 3, 4, 5. Okay, you want to consider this as 1. Okay, 1, 2, 3, 4, 5. Okay, so then that is 5 factorial. Okay, times, then you have to check how many are here inside 3. That one is 3 factorial. That means 5 factorial times 3 factorial. That's all. Okay, check in your calculator what is the answer. 5 factorial times 3 factorial, 720. That means as per that condition, there are 720 different ways they can park. What is the condition? These 3 silver cars must park next to each other. So what you want to do, guys, to find the answer easily, consider this as 1. 1, 2, 3, 4, 5. Okay, that is 5 factorial times these 3 cars. How can they park? 3 factorial. That means maybe this car can come here, this one can go there, this one can come here, this one can go there, like that. Okay, that is inside this one 3. That means 3 factorial. So 5 factorial times 3 factorial, that is 720. So as per this condition, there are 720 different ways they can park the car. Okay, so guys, that's the end of November 2014 question paper. So I hope you understand. Let's see you on the next class. Okay, thank you.